Hello everyone, welcome to the lab tutorials of microcontroller and embedded system coded BCO601. I am Sahana RS, Assistant Professor, Department of Information Science and Engineering, Rajiv Institute of Technology, Hassan.
In today's video, we shall discuss about the first program, that is to develop a program to multiply two 16-bit binary number using assembly level program. Write our program. So double click on Kill Microvision. Okay. Now, before starting your new program, first go to project. If it has any existing projects, do close the project. Click on close project. You have to start it fresh. Okay. Then after closing the old project, go to project, new Microvision project. You can give the name as your wish. Okay, I am giving it as Program1. Save. Then you have to select your microcontroller. The microcontroller we are using is NXP LPC2148. Okay, first you have to search for NXP. Okay, under NXP you have to search for LPC2148. This is the microcontroller we are using. Okay, this is our microcontroller, which is an 32-bit RISC microcontroller. Then press on OK. Then a window will be popped up and it is asking for, do you need to add any startup files? For software programs, we don't add any software files or startup files. So you have to click on no. Keep remember this. You have to click on no. Then you can observe under project we have a target created. Okay. Then to write the program, go to file, click on new. This is the window where you are going to write program. So each and every time when you start your program, give an tab space, then declare some area to store your program, type area, then give name to your program. You can give, here the ALP program which I am considering is multiply of 2 register content. So I am giving name as multiply. You can add 2 register contents, subtract 2 register contents, or multiply 2 register content. Here I am multiplying 2 register content, so I am giving a name as multiply. Then the thing we are writing here is code. Then write read only. You have to mention whether you are reading to your memory or you are even reading and writing to your memory. Here we are only the memory, we are not writing anything to the memory, so we are writing read only. Then enter. Then without any tab space, you have to type entry, which means you are entering the main program here. Enter. Then write start. The code is starting from here. Okay. After that, give a tab space. To multiply 2 register content, first we need to move a data to our registers. Okay, we have R1 to R15 registers in microcontroller. Now firstly I am move R1, comma, hash 1 to 4. So if I am using 4 numbers, it means I am writing 32 data, because to represent each and every number we have to store 2 values in the register. Firstly, I am storing my first value in register R1. every line code has to be ended with semicolon. Next value I am storing it in register R2. Here hashtag represents we are passing immediate data. Okay. Next, MUL is a keyword used to multiply two register content. The third line code is okay, which means R1 and R2 are multiplied and stored in R3 register. Okay. After this, we have to end our program by typing stop branch stop to stop the particular program. After that, write end of the program. Okay, then we have to save the program. File, save. We have to save the program with an extension .s or .asm. Okay, then save. As soon as you save your program, the code color changes. Okay, then after doing this, we have to go to source group, right click on it, then add existing file to source group. Then you have to add the code which you have saved. Okay, here in type of file, click on all files. Then you will get program.s. Click on it and press add. Then you close this window and you can observe you have you have added your file here. So to check whether we have any error in this particular program, we have to build the program. Okay, you can see here we have translate. Click on it. It is showing 0 error, 0 warning. Then build it. Again we have 0 error and 0 warnings. Then rebuild it. After this, we get to know that we don't have any error in the program. Then we have to observe the output. To observe the output, go to debug, start or stop debug session. Then a window is popped out. It is asking for usage of your memory. Click on OK. This is the window where you observe your output. So these are all the registers you can see here. Okay, we have register from R0 to R15, among which R0 to R12 are general purpose registers, where R13 is called as stack pointer, used for exception mode to specify the stack pointer. Next is link register, which is holding the return address when an subroutine is called. Next, program counter, which holds the current address or current execution address. So next is we have CPSR, that is current program status registers, where N represents negative flag. If the result is negative, then this will be 1. N is 0 flag. If the result of your operation is 0, then this flag will be set. Then C represent carry. If the operation is generated carry, then this flag will be set. V represents overflow. If there is any overflow in your operation, then this flag will be set. I means interruption. Then F is fast interrupt. If you have any interruption in between your programs, then this flags or this registers will be set. T represents thumb instructions. Then M represents in which mode your program is running. Okay. Then you can go step by step execution, or you can run overall program at a time. Better you prefer step by step execution, so you can observe output clearly. So first line is we have to move value to register R1. Okay. So as I told, go for step by step execution. After the first step execution, we have seen move R1 6400, but You can observe in R1 we have 19,000 because the value we have entered, this value we have entered is in decimal, but the microcontroller will convert our decimal value to hexa value. So 6,400 decimal value is, hexadecimal value is 19,000, which is moved to R1 register. Next is 32,000, which is to be moved to register R2. Till now R2 value is 0. After running this particular line, R2 value will be stored with the hexadecimal value of 32,000. After that, the multiplied value has to be stored in R3. Okay, run that line. You can observe the R having the multiplied value, hexadecimal value in R3. Okay, after that the execution stops. Okay, these are the three values we have to observe. This is all about the first program. Okay, now I don't want to convert my value. I have to write only directly the hexadecimal value. Means you have to go to debug, stop. If you want to do any edit, first you have to stop your execution, then you have to edit. You have to type 0x before writing any number, which means we are representing number in hexadecimal value. After doing each and every edit, we have to build the program again. Okay, again debug, start or stop debug, press OK. So now you can observe the same value which you have written has moved to the register R1 because we are already representing the value in hexadecimal. Therefore, there will be no conversion of your value. Directly the value which you have written will be moved to your register content. Same thing happens for the second register R2. We have written 32,000 in hexadecimal value. So same value will be moved to register R2. Okay, after the multiplication, the result will be stored in R3. Okay, this is all about our first program. So you can also use add keyword to add two register content, or subtract keyword to subtract the two register content. You can use any of these programs to observe the register content. Thank you.